welcome to Virtual Protocol Podcast. You can ask an AI to write like $1 million app prototype in 30 seconds.
Right.
And it will do it flawlessly.
Oh, absolutely. It's incredible.
But the moment you ask that same AI to actually turn that app on and keep it running, the illusion just completely shatters.
Yeah, it really does.
You are just left staring at a blank terminal window. And you realize you still have to, rent a server, configure a database, figure out the deployment. I mean, the magic trick is over. You are back to being a frustrated human dealing with infrastructure.
Right. And that drop-off, that is the single biggest bottleneck in tech right now. We have these incredibly capable digital brains, but, we keep them trapped inside browser windows.
Exactly.
Sure.
Trapped in a chat box.
Yeah. They can hand you a list of instructions, sure, but they lack the physical or, digital hands to actually build the house they just designed.
So today, we are tearing down that bottleneck. We are synthesizing a fascinating developer case study, a breakdown of Abacus AI's technical documentation, and discussions from the broader vibe coding community to understand this massive shift in how software is made.
And it is a massive shift.
We are looking really closely at a feature from Abacus AI called Supercomputer. The mission of this deep dive is to explore how we are moving away from AI as a smart snippet generator and toward AI acting as a fully autonomous engineering team with its own dedicated cloud infrastructure.
Yeah, and to grasp the magnitude of this shift, we really need to trace the evolution of vibe coding. It started with simple prompting in a chat interface,
Read
right?
and copy and paste.
Exactly. Then we advanced to local tools like OpenAI's Codex, where the AI could actually manipulate your local environment. So it was creating files, writing scripts, executing code directly on your laptop.
Which feels like a superpower, until you shut your laptop at the end of the day and your app just goes offline.
Right. Because the glaring limitation of local vibe coding is that it's completely tethered to your physical hardware. If you want a database that runs 24/7 or, an autonomous agent that collects data while you sleep, your local machine has to stay awake.
Yeah, which no one wants to do.
Exactly. So what Abacus AI did with this supercomputer feature is decouple the AI from your laptop. They gave the agent its own permanent body in the cloud.
Oh, wow. A permanent body.
Yeah, it gets a dedicated Linux server, terminal access, persistent memory, and the authorization to install its own dependencies and databases. It just stays online indefinitely.
Okay, let's unpack this. Because handing a cloud server over to an AI sounds incredibly powerful, but it also sounds like, frankly, a recipe for chaos.
Oh, it definitely can be.
Right. Like, how do you actually control a cloud-based entity? You can't just type, build me a cool app and expect it to spin up a server perfectly. Our sources dive into a specific case study where a developer used the supercomputer to build a really complex personal AI Wikipedia for their Mac.
Yeah, and they operated it entirely through a Telegram bot, which is so cool.
It is. But they didn't start by writing code or even asking the AI to write code. They started by becoming a technical architect.
Right. They started by writing the specification, or the spec. In the Abacus documentation, this is highlighted as the absolute make-or-break step.
Make or break.
Absolutely. The creator in this case study used GPT Pro, which, by the way, is bundled into the $20 monthly Abacus subscription to translate their high-level desires into a really rigid technical document.
So they didn't just wing it.
No, not at all. They detailed the exact input methods, the storage requirements, the transcription models, and the local search parameters. All of it.
Wait, I have to push back on this a little bit. Because the whole sales pitch of AI over the last year is that I don't have to write massive technical manuals anymore.
That a lot, yeah.
Shouldn't the AI just inherently understand that if I want voice notes saved, it needs to figure out transcription? Like, why am I doing the heavy lifting of writing a blueprint?
What's fascinating here is how large language models actually handle contextual memory and global state.
Okay.
Because if you skip the spec and just give the AI a vague command, it starts generating code linearly. It might build your database to handle text, but then, 3 steps later, it realizes you also want to send it audio files.
Oh, I see.
Right. So now the database schema is completely wrong. The AI has to tear down the tables, rewrite the migrations, update the routing logic. You just burn through computing tokens and end up with this fragmented, Frankenstein-like application.
That sounds like a nightmare.
It is. The spec gives the AI the global state of the project before it writes a single variable.
Think of it like a kitchen. If you hire a master chef and you just stand behind them shouting random ingredients like, oh, and I want carrots and maybe some fish, they are going to panic.
Oh, completely.
They'll waste ingredients and serve you a mess. But if you hand that same chef a complete detailed recipe before they even turn on the stove, they can prep the stations, time the cooking perfectly, and deliver a masterpiece. I mean, the AI is the chef and the spec is the recipe.
Yeah, that is a much more accurate way to look at it. The supercomputer agent takes that spec and literally converts it into a sequential logical checklist.
Going down the line.
Exactly. It moves into its dedicated terminal space and starts ticking off boxes, building the infrastructure layer by layer.
Well, let's actually watch the machine build the machine here, because the architecture it spun up in just 30 minutes is staggering.
It really is.
It didn't just make a simple HTML page. Our case study outlines a highly specific 7-layer architecture.
Yeah.
Let's start at the very edge. Like, how does the user actually talk to this cloud server?
So the first layer is the input interface. The user wanted to use Telegram to send data, right? So they went to Telegram's bot father, generated a secure API token, and basically handed that token to the supercomputer agent.
Okay, so they give it the keys.
Yep. The AI then configured the cloud server to open a webhook, which is constantly listening for any data payload sent to that specific Telegram bot.
So the user's walking down the street, they have an idea, and they just text their own private bot on Telegram. Or like they send a voice memo or paste a web link.
Exactly. And that leads directly into layer 2, which is the backend and data routing. This is where the AI really showed its engineering chops.
How so?
Well, it didn't just dump all that data into a single folder. It set up a relational database and wrote logic to categorize the incoming payloads. But the voice memos required a special touch.
Right, because text is easy, but audio is hard.
Yeah, the server only receives an audio file, usually an OGG file. The AI independently determined it needed to install Whisper, which is OpenAI's open-source speech recognition model, directly onto the Linux server.
Wait, really? It just decided to install another model?
Yes. So when an audio file hits the server, the logic routes it to Whisper, Whisper loads its neural network weights, translates the sound waves into text, and then passes that text string into the database.
That is wild. The AI is essentially installing other AI models to act as its own subcontractors.
It's incredible.
But storing the text is only half the battle, right?
Yeah.
Because the user wanted to be able to search this massive personal Wikipedia later. This brings us to layer 3, the brains. The AI implemented vector search.
Yeah, vector search.
For our listeners who are familiar with search but maybe haven't built a vector database themselves, the AI isn't just setting up a basic keyword finder, it's actually mapping the meaning of the words.
Right. It is converting the user's notes into vector embeddings. So instead of saving the word dog as the letters D-O-G, it uses an embedding model to map the concept of a dog into a high-dimensional mathematical coordinate system.
Okay, so the word dog gets assigned a location, like a GPS coordinate, and the word puppy gets assigned a coordinate right next to it because they mean similar things.
Exactly.
If I search canine, the database doesn't look for the letters. It calculates the mathematical distance between my search term and the stored nodes, finding the concepts that live in the same neighborhood.
You nailed it. And to power that conceptual mapping and handle all the organization, the supercomputer attached a local AI model to the database. And the case study highlights a critical strategic choice here.
Okay.
The agent deployed a model called Quinn.
Yeah, I am looking at the documentation here, and that seems counterintuitive to me. If you have access to a supercomputer environment, why would you use Quinn? Like, why not plug in the most massive, frontier-level reasoning model available to act as the brain of your personal search engine?
Right. It seems weird at first, but it comes down to inference cost and latency, which developers often refer to as time to first token.
Okay.
Using a massive frontier model to categorize a 3-sentence grocery list or transcribe a quick voice note is honestly like using a sledgehammer to crack a peanut.
It's just overkill.
Exactly. It takes longer to load the model into memory, and it burns significantly more computing credits. Quinn is a smaller, highly efficient open-weight model. The AI architect realized that for basic tagging and routing tasks, a smaller model keeps the system lightning fast and, more importantly, economically viable to run around the clock.
That makes a lot of sense. So now the AI has a brain, it has a memory, and is processing data on a Linux cloud server. But the user in the case study is on a Mac. They wanted a native Mac OS application to search their notes, not some web interface. How on earth does a Linux server build a Mac app?
Yeah, this was easily the most fascinating technical hurdle in the whole case study because operating systems have totally different architectures, right? You cannot simply compile a native Mac application directly on a Linux server without really complex cross-compilation tool
Yeah,
chains.
they don't speak the same language.
Right, and the AI recognized this environmental limitation.
It's like having a brilliant British architect designing a traditional Japanese house. The architect knows exactly how the house should look. They can draw the perfect blueprints, but they don't have the local materials or the physical environment to actually hammer the nails. They need a local builder to execute the plans.
Yes, that is exactly what happened. The supercomputer played the role of the architect. It wrote all the Swift code for the Mac application, organized the directory structure, packaged it up, and then paused.
It just waited.
Yeah, it essentially turned to the user and said, I have built the app, but you need to compile it on your local hardware. Open your Mac terminal and paste these 5 exact commands.
Oh, wow.
The AI provided a step-by-step shell script for the user to download the package, install the necessary Mac dependencies, and compile the native application locally. It completely bridged the gap between its own cloud environment and the user's physical desktop.
30 minutes from a blank page to a functioning multi-platform AI ecosystem. I mean, it feels like science fiction.
It really does.
But we need to ground this in reality because code breaks. The British architect's plans might have a flaw, or the local builder might drop their hammer. The source material is actually surprisingly transparent about the bugs encountered after that 30-minute sprint, which is refreshing.
It is. The bugs prove this wasn't just some pre-baked demo. There were 3 distinct failures. First, the user experience on the Mac app was flawed. When the user texted a new note via Telegram, the cloud server processed it perfectly, but the Mac app didn't automatically update its interface.
So it was out of sync.
Right, the user had to manually hit refresh to see the new beta.
Okay, and bug number 2 was a data retention issue. The chat history with the search agent wasn't persisting between sessions.
Yep.
And bug number 3 was the scariest one, honestly. When the user was pasting those 5 terminal commands to compile the Mac app, the terminal spit out a wall of red, intimidating error text.
The dreaded red wall.
Yeah. In traditional development, this is where the momentum completely dies. You spend the next 3 hours pasting stack traces into Stack Overflow, trying to untangle package dependencies you don't even understand.
And this is where the paradigm of vibe coding truly reveals itself. The developer didn't try to read the stack trace. They didn't try to debug the Swift code to fix the refresh issue.
They didn't.
No, they simply went back to the chat interface and engaged the supercomputer agent in plain English. For the Mac app, they just typed, the new note saves to the database, but the local app doesn't update automatically. Fix the list refresh.
That's it. And the AI just goes back into its own directory, reads the differential in its code, realizes it forgot to implement a real-time WebSocket listener, writes the patch, and hands the updated code back.
Exactly. And the resolution for the terminal error was even simpler. The user copied the raw red error text from their Mac terminal, pasted it into the chat, and said, I got this error when trying to compile.
Unbelievable.
The AI read the stack trace, identified that the user's Mac was missing a specific Python package required for the build, rewrote the installation command to include that package, and just said, try running this command instead.
Here's where it gets really interesting, and I want to pause here because this is the aha moment of the entire deep dive. Think about the psychological shift happening here. The terminal used to be this terrifying black box where, one misplaced semicolon felt like you were going to permanently break your operating system.
Absolutely. It's terrifying for beginners.
But now, you don't need to fear the errors. You don't even need to understand them. You have transitioned from being a debugger to being a project manager.
If we connect this to the bigger picture, you are taking the complaint from the client, which in this case is your computer, and you are forwarding it to your lead developer, the AI, and telling them to handle it.
Exactly. Here's the error. You fix it.
Coding is rapidly transitioning away from syntax memorization. Vibe coding at this level is essentially an ongoing dialogue with an entity that has memorized the syntax for you. Your job is communication, logic, and management.
If the barrier to entry for building complex, bug-free applications is now just clear communication and management, the implications for businesses are massive.
Huge.
The sources detail a second project that takes this personal workflow and scales it up to a whole team. The creator used the supercomputer to build a custom task tracker for their staff.
Yeah, consider the current landscape of enterprise software. Companies are paying thousands of dollars a year for platforms like Jira, Notion, or Trello.
Too much money.
Right. And these are monolithic applications designed to serve millions of different companies simultaneously. By definition, they are packed with features, menus, and workflows your specific team will never use, yet your team has to navigate around that bloat every single day.
Yeah, we've been conditioned to buy off-the-rack digital clothing. We buy the medium-sized software because it sort of fits our sales team and sort of fits our dev team, but it perfectly fits no one.
Exactly.
This workflow allows you to commission bespoke, tailored digital suits for everyone in your company. The AI built a streamline tracker with only the exact status columns this specific team needed, implemented real-time syncing across their devices, and integrated an AI query layer. So a manager could simply type, "What are the bottleneck tasks for tomorrow?" And the database would just answer.
It is the ultimate operational luxury, a tool built precisely for the contours of your business. But before we declare the death of enterprise software, we do have to talk about the economics.
Yeah, the catch.
Your bespoke tailor analogy is really fitting because bespoke tailors are rarely cheap. How are you paying for this autonomous cloud server?
The documentation breaks this down, and it's not a standard flat rate subscription like your Netflix account. You really have to do the math.
Right. The base cost is the $20 monthly tier from Abacus. That grants you access to the supercomputer architecture and top-tier reasoning models, and it deposits a pool of 30,000 internal credits into your account.
30,000 credits for $20. I mean, on paper, that sounds like a massive runway.
It is, until you look at the passive burn rate of the infrastructure. Just to keep the supercomputer instance active, maintaining the Linux server, keeping the webhooks open for Telegram, holding the database in memory burns 1 credit every 5 minutes.
Okay, wait, doing the math on that, that's 12 credits an hour. If you want your Telegram bot to be responsive at any hour of the day, that server has to run 24 hours a day, 7 days a week.
Which comes out to roughly 8,600 credits a month.
Wow.
Just for the idle hosting of a single project. That is nearly a third of your monthly allowance evaporated before you have even asked the AI to transcribe a voice note, execute a vector search, or generate a response, all of which consume additional credits based on the complexity of the task.
So if you get excited and use the supercomputer to spin up a personal Wikipedia, a team task tracker, and say an automated email sorter, and you leave all three running 24/7, you will burn through that base tier in less than 2 weeks.
Easily. Now, the absolute cost is still remarkably low compared to hiring a DevOps engineer and renting enterprise AWS servers.
Oh, for sure.
You are getting cloud infrastructure for pennies a day. But the cost is highly variable. The community discussions provide a fantastic strategy to manage this, though. Use the AI to budget the AI.
Okay, I love that.
Take the pricing documentation, feed it into an LLM, describe the architecture of the app you want to build, and ask the model to calculate your projected monthly token burn before you authorize the build.
Using an AI accountant to audit your AI developer. I mean, we have come a very long way from just asking a chat box to write a Python script. We are looking at a system that spins up cloud servers, configures databases, routes audio through transcription models, compiles cross-platform code, and acts as a tireless debugging partner.
It is a profound technical achievement, but we must return to the central thesis found across all these sources. Vibe coding is not magic. It is fundamentally an exercise in rigorous thinking.
Right. You cannot just vibe your way to a functional product if your underlying vibes are logically flawed.
Exactly. If you do not deeply understand the business problem you are trying to solve, or if you cannot break a process down into sequential, logical steps to write a comprehensive spec, the supercomputer will just build you a highly advanced, perfectly executed mess.
A very expensive mess.
Yes, the AI is the ultimate execution engine, but the human remains the architect.
So what does this all mean? The barrier to entry has shifted. The wall that kept people out of tech used to be syntax, memorizing the language of machines. That wall has been smashed.
Completely.
The new barrier to entry is clarity of thought. It is knowing exactly what you need to build. This forces a reevaluation of your daily friction. The next time you find yourself doing a repetitive, soul-crushing task or fighting with bloated enterprise software, the question is no longer, is there an app I can buy to fix this? Right. The question is, if I could design the perfect custom solution for this exact problem, what would the blueprint look like? Because the engineering team to build it is already sitting on your desktop waiting for the command.
And that realization introduces a much larger paradigm shift. For decades, human behavior has had to adapt to fit the software we could purchase. But if we are entering an era where you can spin up a perfectly tailored, bespoke application on a Tuesday to manage a specific project and simply delete the entire infrastructure on a Friday because it only cost you $4 to operate, how does that alter our relationship with digital tools?
That's a great question.
Are we witnessing the beginning of the disposable software era and the end of the one-size-fits-all application entirely?
A completely bespoke digital ecosystem built on demand and discarded when the job is done. I'll tell you what, the terminal window is no longer a place to cry. It is just a staging ground for your architect's blueprint and a machine ready to build. Welcome to Virtual Protocol Podcast.